Hello everyone. Uh, we are going to start with the topic that is MSAM 8686 assembly. These are my teammates Prateek Naik, Adithya, Sathwik, Suhas, and me. I will start with the introduction to MASM 8086 assembly. MSM is an assembly language tool for the 8086 processor architecture that is commonly used for writing low-level software such as drivers, operating system components, and firmware. MSM provides support for various data types such as byte, word, and double word, as well as different addressing modes such as direct, indirect, and text addressing. MSAM can produce executable files in various formats, including .com and .exe. It makes it a versatile tool for developing both standalone applications and components that can be integrated into larger projects. Thank you.
Hello, I am Prateek. I'm going to explain about how to write the code in the MASM 8086 assembly using DOSBox. First, I will explain about the background about MASM and DOSBox. Microsoft Microassembly is an assembler that uses Intel syntax for MS and DOS and Microsoft Windows. DOSBox is a free and open source emulator which runs the software for MS-DOS compatible disk operating system. We are actually mounting this MASM on DOSBox and we are writing the assembler code on MASM. So first I will explain how to install DOSBox and mount the MAS file, that is 8086 file. Okay, to install DOSBox, I have provided the link for the download and you can download it and install. The install setup is very easy. Next, and click on the file location where you want to keep this file, a DOSBox file. Then you can install it. I will save it on C drive. Actually, I have installed it already. Then I will provide the link for the another file for 8086 file. Okay, you have to move the 8086 file in the DOSBox file which I have installed. Okay, I have moved this 8086 file in the DOSBox file. Okay, in order to run, click on the DOSBox exe file. The DOSBox file will be open. First, in order to write the assembly code, we have to mount 8086 onto the DOSBox. To mount this, we can use the command mount and the location of the 8086 file, that is it's in DOSBox, that is C drive DOSBox. Okay, the drive is successfully mounted now. So you can see it's in the Z drive. We are working on the Z drive, so we have to turn it into C drive. So to turn it to C drive, press C and a colon. Okay, now it's on C drive. So in order to create the file, use the command edit and the file name. I will keep the name file name and with the extension ASM. Okay, press the enter. So here you can write the code and you can save the code using save and you can exit here. I have already created a file which gives the output hello world. I will show that file. Yes. So this is the code which returns the hello world as the output. I will show how to run this code. To run the code, first we have to check for any errors. To check the errors, type the command MASM file name hello.asm. So this will check for errors. So you can see there are 0 warnings and 0 errors. So we can go ahead for linking the file. To link the file, we can use the command link and the file name hello. Okay, the file has been successfully linked now. To run this file, write hello.exe. Okay, there is an output hello world. That's it for this. Thank you for watching.
So my name is Suhas. So I'm going to explain you this code. This is assembly language code, simple code that copies the content of one array to another. This block of code defines the segment called X segment. It can also be called as data segment. This block contains two arrays names array1 and array2. Array1 contains four 16-bit values represented in hexadecimal notation. Array2 also contains four 16-bit values, but they are initialized to 0. There is also a variable called count, which is a 16-bit word that is set to 0. The block of code defines segment called Y. Basically, this code segment where our actual operation code is written. The assume CSY and DSX instruction is used to specify that the code segment Y is associated with the data segment X. The begin labels mark the beginning of the program code. Move X and move DS AX code move the starting address of the X segment to the DS register. Move SI offset array1 and move DI offset array2. This code initializes the SI and DI registers to the starting addresses of the array1 and array2 respectively. CX register is set to value of count, that is 4.
Hello guys, thank you Suhas for explaining the. From here, I'm gonna explain. My name is Sathwik. Explaining the code. The back label marks the beginning of the loop that will copy the value from array 1 to array 2. Inside the loop, the 16-bit value at the memory location is pointed to by SI is moved to AX register using move SI is moved to AX instruction. This value is then moved to the memory location pointed by DI using move DI AX instruction. मतलब move AX is moved to DI. The SI and DI registers are then incremented by 2 to point to the next 16-bit value in each array. The CX register is decremented by 1 because to increase the value of the count in order to stop the looping at the particular time. JNZ back instruction causes the loop to repeat until CZ is 0. The move AH 4CH instruction moves the value CH into the AH register, which is the code for the terminate program function in the DOS. The int 21H instruction then causes an interpret to occur which transfers control to DOS operating system to terminate the program. Y ends directive marks to the end of Y segment matlab data segment. The end begin instructions mark the end of the program. Here the program ends, and thank you guys for watching.
Hello everyone, this is Adithya Naik. So instead of PPTs, I'm using just a notepad over here, and just for that understanding purpose and for our convenience. And I'll be explaining about the code generation part. So let us take an example of move the MOV, that is move AX4880. 4880 is basically a constant, or you can say that has to be moved elements, and AX is a register where move is a instruction command. So now I'll just write the general form. It's a kind of general form just for understanding. So I'll write 0000. This is opcode what we say. And next will be the W bit. W bit in a sense is just a word operation what we say. So what I mean the W bit represents the word operation. If it is a word operation, W bit will be 1 or it will be 0. So next three zeros or the 3 bits will be the register. So now let's understand what exactly opcodes. So opcode move, opcode for move is 1011. So that will be an opcode for move command. and W bit will be 1 for the word operation, what we say, and then the register. The register which we have used here is AX. So the code for AX over here is just 000. So now let's convert it into hex code. Uh, 10, I think all must be knowing how to convert it to binary into a hexadecimal code, that is splitting it to 4 plus 4. So this 4 will be around the B. Yeah, it will be B. And this will be 8. Yes, 2 power 3, that is 8. And we'll write this 48AD in little endian method. So little endian method, in the sense, this is a least significant bit. The least significant bit in this will be represented first, and the most significant bit will be represented the next. So here we'll write AD first, and then it will be 48. So ultimately, the machine code will be B8AD48. So this is a machine generated code. Uh, in the sense, machine generated code is nothing but the machine understandable code, where this move x48ad is a human understandable code, that what we write as almost as a language, we can say. So I'll take an example of one more instruction, that is mov, I mean move si 0000. So this, if this is one more example, let me give some space over here. So now again, I won't write the general formula. So again, the move is 1011, as we mentioned earlier. W bit will be 1. So now the code for SI is 110. So when we convert this into hexadecimal code, again 1011, that will be represented as, again, as B, as we all know. B, I mean, it's I think you will be all will be knowing that is 2 power 0, 2 power 1, that will be totally 3. This is a 0 bit, and 2 power the 3 will be 8. So 8 plus 3 will be 11, will be represented by B. And now this 1110 will be E. So this will be E. And we write again 0000. However, nothing plays any impact over here, since two bits are also same. So, but this zeros will be represented here. That is least significant bit will be represented earlier, and then the most significant bits in the little endian method. So now we use BE0000. This will be the code, machine code, for the instruction move SI to 0000. So that's it for the code generation part. Thank you.
Please like, share, and subscribe.